Hey, this is Acee, and this is the second home video lab report for Physics 2211. So what we had to do was we had to drop an object and analyze its motion downwards towards the Earth. So my first video was me holding a sandal up and dropping it to my dorm room floor. So what I did is I put it in tracker. Right here. Here's the video. What I did is I twisted the axis around to where the x-axis was vertical. Next, I put a calibration stick on an object that I knew was 4.5 centimeters in the diameter here. And then basically I just tracked the sandal as it fell to the floor here. Then I got a graph that looked like this. My second video was I did the same exact thing where I made the same calibration stick and same thing with the axis, except now I had a sheet of paper that was folded in half, as you can see right here. Then as I dropped it, I then tracked it 7 times here and got a position versus time graph that looked like this. After I did the tracker, I made a computational model in Python, as you can see right here. So basically, what I did is for the sandal, I said that the drag force was equal to 0, and I just installed Newton's laws here into a while loop, which would constantly update the position, velocity, and acceleration of the sandal. So then when I ran this, I got a graph that looked like this, which is perfectly parabolic here, which showed that there was a constant acceleration on the object. My Python program for the piece of paper ended up giving me a graph that looked like this. For some reason, the Python program went open. But basically what I did was, for the drag vector here, I just I made it positive b times the velocity of the object, which was a piece of paper. So basically, what that did was, as the velocity got bigger, the drag force got bigger, which made the net force approach 0, which is why the graph ended up looking linear as the net force approached 0. So after I did both tracker and Python, I put the data into Excel. This is the sandal being dropped. The red is the Python and the blue is the tracker program. They're pretty close together, but not exactly, because my video camera didn't have quite enough frames per second to get a good, accurate analysis of the fall. So I mean, I only got about 4 time frames in here, so I mean, it's not the most accurate thing, but I mean, it's still pretty close to what the Python gave me. Then I also put the tracker and Python data of the piece of paper here. Again, didn't have very many frames per second, so the Python and the tracker aren't very close to each other, but they're still both like kind of linear because of the drag force on it, which ended up almost making the net force 0. So that brings us to the 2 questions. First, the what does it mean question, which was for the object that dropped slowly. Examine the velocity versus time predicted by your models with and without drag. Which models, if any, predicts a terminal velocity? That would definitely be the second one here of the piece of paper, because as the drag force grew because the velocity was increasing of the piece of paper, it it almost reached the gravitational force, which would make the net force approach zero, causing constant velocity, or in this case would be terminal velocity, which can be seen here by the linear graph here, which if you took the derivative would give you the terminal velocity. And then the what if question: for the object that drops slowly, use your models both with and without drag to examine the object's velocity as a function of time in the case where the object is thrown downward initially instead of dropped from rest. In this case, does the object reach a terminal velocity? Examine both models with and without drag. Compare the terminal velocities, if any, in this case with the case where the object is dropped from rest. So basically, if the object was thrown downwards, it would basically look pretty much the same as this one, which didn't include drag, except that it would just be shifted downwards a little bit because it was given an initial velocity. Because the acceleration would still, or the force on it would still just be gravity, which is 9.8 times the mass of the sandal. However, for the one that included drag, which was the piece of paper that was dropped, basically if it was given a downward velocity initially that was less than the terminal velocity of this, it would change it just by the fact that it would reach its terminal velocity quicker than if it was just dropped. Now, if it was given a downward velocity that was greater than the terminal velocity of the object, it would still reach its terminal velocity because the initial drag force would overcome the gravitational force, causing a upward net force on the piece of paper until the drag force equaled the gravitational force, causing a net force of 0, which would then cause the object to fall at a constant velocity. So that is it. Thank you very much.